Assalamu alaikum guys. Today the topic of my video is our semester project, that was a line following robot. Basically, we will get to know that what is a line following robot and how can we make it, and what are the steps and how the steps are carried out to run this line following robot. So basically, a line follower robot is a robot which follows a certain path controlled by feedback mechanism. It is basically an autonomous machine in which the feedback is predetermined by the user, and the components used in this project, the line following robot making, is 4 IR sensors. IR proximity sensors are used as the inputs which detect any object approaching towards it and then perform its function. A motor driver L298, this motor driver L298 performs the function as when the outputs of the multiplexers or any gate ICs, for example logic gates, are given. These are given to as the input of motor driver, and the motor driver furtherly gives output as an input to the servo motors that are connected to this chassis body. And we will use logic gates. For example, we will use NOT gate for our inputs, and multiplexer ICs, chassis body and wheels, servo motors, PCB on which this whole circuit will be applied, soldering iron for soldering wires, and batteries for in order to run this operation. Now, the use of IR sensors in this line following robot is that in case of a line follower robot, we use IR transmitters and receivers, which are also called photodiodes. The transmitters and receivers, we basically use an IR transducer, in which you all know there are transmitters, receivers and emitters. So in case of line follower robot, we use IR transmitters and receivers, also called photodiodes. They are used for sending and receiving light, and the light could be infrared or visible. Mostly it is infrared. So IR transmits infrared lights. When infrared rays falls on white surface, it's reflected back and catches by photodiodes, which generates some voltage changes. Usually the visual line is the path in which the line follower robot goes, and it will be a black line on a white surface. But we can other way use white line on a black surface too. It is also possible if we apply NOT gates and inverter to our circuit, so the inputs will be reversed. And so now we will discuss its advantages and applications. They can be used in industries as automated equipment carriers. It can be used for home for floor cleaning as well. It can be used in the vacuum cleaner. In hotels, they are being used for the transfer of things from one place to another, following a straight path. And this is its actual picture. This is a line following robot using Arduino, and our main task was to make the line following robot without Arduino. We were set to carry out this task using without microcontrollers, or using ICs, logic gate ICs or multiplexers. We can use both methods to carry out this project, but in my opinion the multiplexer is easy, as the data configuration or the data sheet pin configuration of logic gate ICs is much complex than the multiplexer ICs. In multiplexer you have selection lines, so it is quite easier to implement than the logic gate ICs. Now, as we earlier discussed, that a line following robot basically is a machine which follows a path predetermined by user. The path could be straight or curved. The line follower robot senses a light using specific sensors. We used an IR proximity sensor. Line follower senses the lines using its sensor LDRs and move the mechanical structure to stay on course while constantly connect, correcting wrong moves. We did this project using a digital electronic components. We have divided the project into following modules. First, we made a mechanical design, then we set the motor speed and direction control, and finally the light sensing mechanism. The mechanical design should be lightweight and stable. It should be able to support the circuit and motors while maintaining the balance during operation. Motors placement: the motors should be positioned in the mechanical structure so as to allow maximum power transfer and torque. Direction: possible methods may include varying the motor speed. We will use LDRs or phototransistors for the light sensing mechanism. The intensity of light reflected from the surface will determine the resistance of LDR, or the amount of current flowing from the collector to the emitter in the phototransistor. This changed resistance or current will determine the speed of motors. A robot will know when to turn depending on the location of the sensors. Number of sensors determines the smooth movement of the robot, and safe distance between each IR sensor depends on number of sensors, width of the straight line, and the logic applied. Now first we discuss that how we made this, how we initialized our project. So it is known as our initial feasibility. The initial feasibility includes the optimization or the steps of the making of circuit we did to design our circuit both through software and hardware. So optimization first requires truth table, that we select our min terms. As we can see, these are our 4 inputs and these are our 2 outputs for both of the motors, servo motors, and we selected our min terms and then made our optimization table for both of the outputs, and then the block diagram for both the muxes, multiplexers, were made, as you can see here. Now we will go towards our schematic diagram, the software part. Here we can see that first we have given 4 inputs through the SIL connectors, the dip switches, and these inputs were given by a logic toggle. You can also give this by an input voltage source. So, and here is our enable, and this enable is connected to our motor driver, and a NOT gate is connected to both of these muxes. If we zoom there, here we can see this NOT gate is the input, and here it is giving our output to the second mux, the right mux, and further LEDs are connected. We will also only check our results through LEDs and leave the motors. The advantage of using LEDs before the motor driver or the motors is that if any defect is found in your circuit, the motor driver and the motor should remain safe, or else they could also get damaged. So here if we can see our truth table, this is our truth table, and when 4 of our inputs, all of our inputs are 0, then both of our outputs should be 0. That is here I have started the simulation, and as you can see, when all 4 of our inputs are 0, both of the LEDs are off. Then we will carry out the next. If D input is 1, the fourth IR sensor which we will place, if the input carried out by that input is 1, then our F1, the left motor, will give us an input of 1. Here we can see the yellow LED has been on, so has been switched on, so our left mux, and similarly the left mux giving the output to the motor driver and the motor driver giving the input to the motors, the left motor will run. Now when the middle inputs, that are B and C, When these two are on, so here we can see both of our outputs will be on. That means it will travel, or it will run along a straight line, and if any of these input is of the middle ones, the B and C, then the robot will still travel or run in the same direction, that is the straight direction. If we on both of our A and B inputs, then the right motor will run. The right mux will give the output to the right LED, that was the green LED. Here we can see the phenomenon that it follows is when the right motor runs, the robot will move in left direction and vice versa. Basically, the line following robot follows a black line over a white surface. We can make a arena. We can make arena by using a white chart, and on that chart we can apply a black tape or any black line, and then we can follow our procedure. Now let's see that whether our inputs and outputs were right. When both of our left inputs were 1, that were A and B, then F2 was on. Now we will see the same procedure for the right. When the D and C input are 1, then our F1 will be on. Here we can see 0 0 1 1 gives us F1 is equal to 1. So that was all for our schematic diagram, and this was our enable. The enable should be 0 because a NOT gate is also applied to it. If we on our enable, then the circuit won't run, and the multiplexer that we used was a 8x1 mux, and its name in the Proteus software, we can search here in component mode, is 74151. This is a 8x1 mux, and these are the selection lines B, C and D, and this is our input given by A and A0, and this is our output. So here we can see, if we see this optimization table, which is further carried out by our midterms. If the midterms is 1, we will circle the position, and here we can see this was our result for mux 1. So we made the mux 1 like this, and same here we can see that all the connections are connected with the help of this block diagram, and these are 3 selection lines which are connected here, here and here, and this is our enable which is connected to this. And similarly for block diagram of mux 2, here we can see these were our outputs, these were our inputs which was carried out by the optimization table of the truth table, and this was our block diagram, and according to this block diagram we made our schematic and did the connections. And here we also applied a NOT gate, as we can see, and 2 NOT gates were used in case of 0 and 5. So here we can see at 0 and 5 we used a NOT gate. Now we will carry out further procedure that were to make a PCB. First of all, we should place all the components, and only silk connectors and multiplexers and motor drivers will be placed. That is because LED is not found in the PCB layout, so instead of the PCB layout, we just have to put the components that have their PCB structure or the PCB layout. So as the inputs, I have placed here the 4 silk connectors, and here are our multiplexers, and this is our motor driver. So here we can see that these all 4 silk connectors have been connected through jumper wires and connecting wires, and through with these multiplexers, and furtherly the multiplexer gives the input to the motor driver. So we when the PCB layout is carried out, the PCB layout somehow looks like this. The PCB layout somehow looks like this. The first PCB that I made was deleted, so this was basically the main PCB, and the PCB layout somehow looks like this. Here are our connections. Only top copper is being printed. So this is our PCB layout, and if you can see these holes, only in these holes we will drill through a drill machine when we will carry out the PCB hardware process. In the PCB hardware process, first of all we apply this sticker to a PCB board, and then we through a sticker, and then we press it for about approximately 10 or 15 minutes, and then we can do the etching with the FeCl3 solution, and furtherly we can drill these holes through drill machine, and finally we can solder them and place the components here, and furtherly give the outputs through motor driver to the servo motors, and then we can check the result. So this was our schematic diagram, and if we want to see the procedure that we carried out, or the tree, it is basically known as let me see. It is basically known as the work breakdown structure. Basically in this work breakdown structure of LFR, there were 3 steps: the optimization, the software development, and the hardware development. In optimization we made truth table, optimization table, and the block diagram. In hardware we made a breadboard, circuit diagram, and PCB, and then finally we checked our results. In software, through Proteus software, Proteus Professional 8.10 or 8.7, whatever you want to use, it's up to you. Furtherly in Proteus we did our schematic diagram and PCB, and then we checked our results as I have shown you already. So now we will see that how this robot works. Thank you.